Dilip sir, good morning. Good morning, sir.
Good morning.
Good morning,
So
sir.
we'll wait for 2-3 minutes, then we'll start, Smriti. I think let us
Sure,
join.
sure.
Yes, sir.
Good morning, Dr.
Good
Dilip.
morning. Good morning,
How are you?
Santipriya.
Yeah, I'm fine.
It's an early morning for you, 6 a.m.
Yeah. So now are you in Singapore or?
Yeah, currently in Singapore, so it's 12. So
Okay.
that's good. Better than you.
Yeah.
Yeah.
Smriti is also in Finland, na?
Yes, sir. So it's 7. Everyone is sleeping.
Then good. We'll finish your work now.
Yes, yes. By the time I complete 2 sessions, then only they'll be awake. So good for me.
And Dr. Dilip, when are you back to Norway?
Oh, Norway, I will be returning on 2nd of August.
Okay. Okay.
So then we will have a workshop there. Remember? Summer school?
Yeah. Yeah, I informed. Actually, I said that about the course, even many people are interested. They are asking
But
me how.
not many are contacting me. I got 8 people interest.
Okay. So I'll share maybe in my group. So let's see. I think, but
Yeah.
some people have asked me. I said, okay, I can contact you
No,
directly.
they can join. So if anyone doesn't want, is not interested in life sciences, then they can do a normal generative AI project.
Okay.
So the importance is that they can do project on low resource language.
Yeah.
Anyone in your team who's working on low resource language can do it.
I think I think it will be good if you can little bit talk about that in your during your presentation. So if anybody is interested, they can
Let's see.
also
Yeah, I will talk.
because many people are joining. They're interested in generative AI, so some might be interested for such courses.
Yeah, yeah.
Dr. Dilip, it's online or Moscow?
It's online. It's online.
Okay, okay. And so you have give some prices there or not, miss? It's
No
free.
pricing. So I'm conducting this course for the university. So now few people ask me that can they join. Now I can let them join virtually, only that they will not get a credit from the university.
Okay, that's no
Because
problem. So
university admission process is finished.
you just share the link to Dr. Santipriya, so I will collect that one because
Yes, sure.
currently, yeah, I have some students of around 30 to 40 African language students are there.
That will be great.
Who is working with me, and I am
Yeah.
in process of translating one book also in 30 languages at a time.
Oh
That
my God.
yeah, so, all are African. So
Oh
I
my God.
may tell to them that they can join.
Yeah, yeah. That yes, they can join. So only that they can get a participation letter signed from us. So if they need to use it, if they complete the project and the course, whatever required assignment and other
They
things,
are
so
doing
they
here
can do
something
that.
BSc and BCA. They have already got some say position, MS position in Prague also. 3 to 4% has got the offer in Prague also. Some university,
Mhm.
university name.
Mhm.
And they are applying here and there in European country like Italy. Bologna University too has got well like that only.
So that is great.
We have here 2,300 outside students are here in
Oh
our
my God.
around all over the world, Kazakhstan, Syria, Bhutan, Sri Lanka, like that.
There is a lot of students.
And some students are there, tribal students of Odisha also, but they don't have any knowledge about the computer. But you can use them to collect the data set like your Santali, Ho, like that, Kuvi. But they don't have
Mhm.
any single knowledge on the computer. Only you can use them to collect the data only,
Mhm.
like that. Currently, I have 3 students of that tribal languages, Kuvi, Ho, and Santali, and Binjal,
Mhm.
4 languages. I am the co-supervisor of the students. So you just
Mhm.
share the link to Dr. Santipra, then I'll collect the link. That's it.
Yes, sure, sure.
Yeah.
Now I think Smriti, you can start or we'll wait for some time. I think we can start, na? Because 9:33, so we'll stick on the time.
Yeah, I think we're already 20, so maybe we can start.
Yes, you can
So,
start.
yeah. So, good morning, everyone. So, welcome to the day 2 of our Generative AI workshop. So, today, Professor Dilip K. Prasad is our first speaker for the day. He is a computer science professor at UIT, the Arctic University of Norway. He is holding a PhD from Nanyang Technological University, Singapore, and he has done his B.Tech from IIT Dhanbad, previously known as Indian School of Mines. Apart from his research roles at University of Nanyang and National University of Singapore, he has also having industry experience at IBM and Philips. So he is a Kauffman Global Scholar and recipient of the prestigious Rolls-Royce Inventor Award. Professor Dilip has co-founded the Bio AI Lab at the UIT, which has secured 24 million euros of funding. He's having over 130 publications, and he has co-authored interpretability in deep learning. Today, he's going to talk about towards a more inclusive AI, large language model training for the ultra low resource language, that is SAMI language. His research focuses on sustainable, scalable, and interpretable AI. Um, let's welcome Professor Dilip and hear more about his study or his research. Welcome, Professor Dilip. Over to you. Thank you, sir, for joining us today. And over to
Yeah.
you.
Thank you, Smriti, and thank you all the audience who are attending this talk. So can I share my screen?
Yes, sir.
Okay. So hello everyone, and good morning, and very, very good morning, early good morning. And if someone is on a different time zone, then good afternoon and good evening as well. So my name is Dilip K. Prasad, and I am a faculty at UIT, the Arctic University of Norway. And so Norway has a total population of around 5.5 million to 6 million. And out of this 5.5 and 6 million population, the Norway has 2 languages. One is Norsk and the other one is Sami. So the number of speaker of Sami language is less than 20,000. And that is how low is this resource language. And the Sami people are typically moving kind of people. In the past, they used to move from this place to that place. And their language is very unique. It doesn't matches with the German and French and all those language. And even the Norwegian language, it doesn't matches. So getting this resource was very hard. And now I believe in a thought that if you want to protect any language, the language is one of the biggest important thing which Homo sapiens have achieved, and that let the Homo sapiens survive and progress. And without the language, we would have not progressed. Every language which has came up lots of language has been lost, and there are every day few languages are going away. So Sami is one of the language, and I believe that by digitizing and by using the modern technology to preserve them, we can keep the importance of this language, and this language can survive for long. So in this regard, this work is that towards more inclusive AI, and how we achieve the large language model training for this ultra low resource language. And in the Sami, Oftas Gesai, which means together we move towards the future. So let's move forward. Typically, when we go for LLM large language model training, and what OpenAI and other big companies who are working in large language model, how they are collecting the data. So they are basically crawling the whole internet, and that is called a common crawl dataset. So the common crawl dataset, which has been collected until June 2023, has over 3 billion web pages. And in uncompressed format, this data is 400 terabyte. So after processing, pre-processing, filtering, deduplication, and everything, so we will be left over with 25% of good quality data. So this 400 terabyte of data, if we convert into tokens, that will result into around 21 trillion tokens. And if we do the filtration, pre-processing, deduplication, other kind of way which we can get a better quality data, we will left with 5.5 trillion tokens. And that is huge amount. If you are working in the large language model training and fine tuning, you probably can guess my next question. How many GPU hours it is going to take if we want to train Llama 3 using A100 GPU card for these 6 trillion tokens? Any guess? So just to let you, the amount of hours it is going to take is 18 million A100 GPU hours, which is huge. So the biggest GPU cluster which are available to Google and Facebook, they have roughly 27,000 to 30,000 GPU cards. And if we try to calculate that, if we take the complete those 27,000, 30,000 GPU cards, still it is going to take years. And so far, people have not used this complete dataset for training. In future, they are going to use it. Now, going to Sami, how Sami language is, what is this language? How many speakers are there? As I spoke earlier, there are less than 20,000 speakers are there. And Sami is a cluster of language. It's not a one language. Within the 20,000 speakers, there are 10 dialects are there, and out of them, 2 are extinct. One language, last speaker died in 2003. So now no more person is there who can speak that language. So there are 8 languages are there. And majorly Northern Sami is the language, the Sami language people are speaking at the moment. So Sami language is not available in any of the dataset corpus. We do have no language left behind by Facebook and other corpus where 160, 190 languages are there. In those languages, Sami language dataset is not there, and that is why there is no foundational model on Sami language. So we try to collect the Sami language resource via doing the web crawling. First of all, in our team, none of us know Sami. I practically do not know anything about Sami. And the master student who has worked on this topic, he also is a Norwegian, but he also doesn't understand Sami. So we will come to know what is the size of this Sami resource, when we did a web crawling, and what we got in next few slides. So the importance of this AI, if we really want to see what it contains in this LLM training data set, which is available online, as we know that English is a dominated language in the worldwide, especially in the digital world, the English is used massively. Everything we read mostly in English. Or then the developed countries like European languages are there. So if we go for this data set, 95% of the data is dominated by this developed country. And there are many African languages, Indian languages, and many languages in Timor-Leste, Indonesia. They're not there. And there are no speakers and not much digitization there. So if a particular society needs to progress, their language need to be included in this modern technology. We are at the moment of industrial revolution 4.0, and if we do not take advantage of modern technology like generative AI, then the opportunity in those languages is going to be harder. So how inclusive AI for language can help a particular language? It can preserve the cultural heritage, and it can increase the visibility. For example, I have traveled worldwide, and most people think that Hindi is the language of India, but they do not know that India has over 1,000 languages and there are 22 official languages in the country. Odia is one of the language. So not getting the visibility, people, its opportunity and other things are going to be harder. Then if any company coming from this place, let's say from Odisha, and they have developed something in Odia language, or they have a people who can only speak Odia, not knowing English will lead them lots of economic opportunity. But having this kind of language inclusion can help them get a better education, market expansion of those company, and the job creation. And finally, in the community of Sami language, especially the older generation who are 40 plus, they also do not speak Norwegian, and they do not speak English as well. Now, when they go to see the doctor, they find difficulty in explaining what they are feeling. And then you need to get a translator and getting a healthcare and public service. And imagine if they get into a danger, emergency situation. And when you are into the emergency situation, you are going to speak your own language. When you are angry or in a distress, you are going to speak your own language, and they won't be able to call for help. So this inclusion of Sami language in that place where the population is very sparse and the country is too big, how big is the country in terms of land area? Around 7 Odisha can come into the Norway land area. It is that big, but only 5.5 million population is there. So sparsity of the population also makes the people vulnerable if the natural disaster happens. So that is why the importance of languages are important, and that's applicable for every language in the world. So what are the different low resource language models are there? When we go for models like there are Ember, which is pre-trained on 104 language, and Roberta, around 100 languages are there. Then initial very early language like MT5, that also many of us uses because we lack amount of GPU resources. So we start with a T5. And then recently the Indic language, the focus on Indian languages are there. So Indic BERT, then Indic LLM Suite and other languages are coming up, models are coming up. And then FinBERT, which focus on Finnish and Uralic language. Why I'm talking about FinBERT? Because Sami is a Uralic language. It's very similar to Finnish, Estonian, and Hungarian. So the similar kind of language, if you think, for example, if we talk about the language connected to Indic, there are all Devanagari language. So Uralic language, Sami, Finnish, Estonian, and Hungarian is there. Normally how we collect the data set by doing common crawl, and then the Oscar kind of initiative came up where they are combining languages from multiple data sets. It has 166 language. Then the Universal Declaration of Human Rights data set is there. CC100 has over 100 languages from common crawl. Flores 101 languages, and then Indo-NLU has Indonesian language, 10 languages, and then African language called Paskani. And there are many other African initiatives are there where they are trying to include, because Africa has lots of diversity culturally and linguistically. And among the many languages, the Ghumla has the number of speakers higher than Sami language. And that is one of the least spoken language in Africa. So you can understand the Sami is how low resource language it is. There are many initiatives are going on to preserve low resource language like AI for Bharat and OdiaGenAI. Then Gupden project, they are targeting many small minority languages. And then Linguistic Data Consortium, they are also working on this low resource language. So recently, there is a data set came up by initiative by researcher from IIT Madras and AI for Bharat. Sangraha. Now, Sangraha is a combination of 22 Indic language. And if you see in the table that it has almost 48 billions of tokens, so among 22 language. And the number of PDF pages are in 14 billion PDF pages. And there are also speech records are there. So among this language, if we go to see the number of token present, for example, the language called Dogra, which has 300,000 tokens. So which is ultra low resource language, 300,000 tokens. And then Santhali, that has 600,000 tokens. Sanskrit is an old language. It has a very less speaker, but it still have 54 million tokens. Now, how these data sets have been collected. So going through this data set collection of other languages, we can get an insight if you want to work on any new language which is not covered in the major languages dataset, how to proceed. So Sangraha dataset has been collected via Internet Archive, via eGyan course, where the different books and documents are being digitized, Indian Parliament proceedings into different languages, then All India Radio News converted into different languages, government gadgets and magazines, school books of NCERT, CBSE, ICSE, which are converted into different languages, and miscellaneous records, even like Man Ki Baat by Prime Minister Modi, that has also been quite a good resource for quite good translated language into many languages. And in Sangraha datasets, almost 500,000 PDFs are there with 82 million pages. And looking into this, if we want to proceed to any language, we can understand that how we are going to get and collect the dataset. So the number of speakers of Indian languages, if we want to see, one of the least spoken language in the Indian languages is Sanskrit, which officially, as per 2011 data, 24,000 speakers are there, which is considered an indigenous language in India. Sami has less than 20,000 speakers, and with time, less and less people are adapting or learning their own language. Even the Sami people are not learning their language. Now, how we collected our Sami language dataset. And this is a beautiful place where Sami people lives, and this kind of aurora borealis we can see. I hope Dr. Santi Priya has also seen from Helsinki, but it is visible from Prof. So let's move to this work has been done by my master student Ronnie Paul and postdoc Himanshu Bokchas, and also with the supervision from Dr. Santi Priya Parida, who is an expert in the low resource language and is one of the leader in Odia Generative AI. This particular language is considered an endangered language as per UNESCO. And if we see in the map, this language is spoken across Sweden, Finland, and Norway. And the Sami people are allowed to travel across this country. And Sami people hold dual passport. They have a Sami passport and they have a Sami parliament, and they have their own country passport like Sweden, Norwegian, and Finland. So this language was endangered. In Norway, they got a special place. In 1989, in order to protect Sami, they given them the reservation. So Norway doesn't have a reservation. So first time they came with a reservation in order to give them opportunity and also hear what they think, because there are only 20,000 speakers and they are into so many countries. Politically, they cannot provide any kind of opportunity so that they can represent in parliament. So they had been given a reservation in the parliaments in Norway, as well as Sweden and Finland. And this is a category of Estonian and Hungarian and Finnish. 8 out of these 10 dialects are already endangered, and so we need to protect it. Lots of fundings, lots of money is getting invested to protect this language. There are Center of Sami Studies, and there are a lot of representation and promotions are there on Sami. Just like we are trying to protect Sanskrit language by giving them the Sanskrit news and other things, so they are also trying to get a Sami TV channel, funding from the government, and all those things are happening. There had been apprehension that will the Sami language disappear, article by Sami people. There are 10 Sami language, I told you. 2 languages already disappeared. Most of the languages spoken in Sami are actually northern Sami. And within a beautiful country, this particular picture is taken by me. It's a very nice place. So now question comes, can generative AI preserve Sami? And that is our movement towards preserving Sami via preserving them into the large language model. What are the challenges we faced when we worked on this ultra low resource language, Sami? First of all, the amount of online and offline resources available to this language is very limited. And if we think like, okay, if you want to create a synthetic data for Sami language, so let's take any other language or English language and use the GPT-3 or OpenAI or any open large language model and translate into the Sami language. They are not there. Means if we use OpenAI to convert into Sami, the translation is not correct at all. It does give the Sami prediction, but the translation is incorrect. So the support from the mainstream language model is not there. That is one of the challenge, and the number of speakers are not much available. So cost and complexity of manually collecting the data is high. So due to lack of native speaker, we were not able to do major advancement in this, but whatever online was available, we were trying to collect it. And not knowing this language, and this language is very different from even the people who speak Norwegian doesn't understand at all, and they can't even read this language. So that is one of the barriers. Now, data shortage is their operability issue while working with large language model. For example, the models which are trained on a particular category of language, let's say if I take a language which has been trained on Germanic language or Roman language like English, and the language which are similar to English, and if we use the Indic language or a Chinese language to train those pre-trained model, the performance what we have seen is not good, because the language construct of these languages are different. The grammar construct and the way they are being the language formation is there is different. So the amount of data needed to train the pre-trained language which are being trained on a different type of language is high, and we are already working with ultra low resource language where the data set is not enough available, and that brings the challenges. I am into the Norway since 2019, and I do understand Sami is a very sensitive issue in Norway. It is very, very similar to, we used to have the upper class and the lower class and reserved category and unreserved category kind of sensitive issue, and presently the minority and non-minority issue. So Sami is that kind of ultra sensitive issue in Norway. Now, the Sami communities, like in my university, there is a department is there, Sami department. And in 5 years, I have tried to bring them. There are 13 researchers are there, Ph.D. and faculty. None of them even reply to the email from your own university. So they are completely afraid and scared that they really do not want to get a large language model for their language. They are getting funding for digitization of Sami language. What they provide is that from any other language to Sami language translation, but not from Sami to other language. Means if you have an English text, they have a digital resource. You can manually type the text and you can get the Sami translation. But if you put a Sami language to translate into any language, there is no service available. And that is their thinking and thought process, that they feel like if they digitize the reverse conversion, then their language is going to lose. So we are not able to get any support from any Sami speaker in the university. And the other thing is that this particular project is not funded by any grant, so we can't even hire any resource for working on it. So that was a big challenge. In 5 years, I'm not able to bring any Sami related researchers on board. But I'm able to bring the other people who are working in linguistics and they understand Sami. So we got some help from them. Now, the contribution of us in this particular work is we actually collected the Sami language, we compiled, we processed, we did a data filtration, and we tried to find what way and what type of foundational model category, like decoder only, encoder decoder, or PLM kind of language, what type of foundational model can be useful with this least amount of data to be trained, and the language which is very different. So we did try cross-lingual transfer learning, multilingual training, and then finally we developed the foundational language model for Sami. So what are the prior work done in the Sami language model? So there are some rule-based statistical models people have tried to work, to where they were use the SVM and those kind of classical AI to find lexical and morphological analysis, and also to understand the form generation. There are statistical model developed, because Sami particular language, one thing I have observed is that Sami words are pretty long, means 15, 25, 30 characters words they have. maybe they are connected words, as I do not understand Sami. So there are n-gram study, graphical study are there. Some linguistic researchers have done that study. So to move to the data collection, I got the help from the linguist department, Professor Laura Janda, because we also didn't know how to proceed. Where is the data available? So she given the source like this Gilatechno, and this particular source is developed by the Sami department of our university, but we cannot get access to it. And what we did the web crawl. Luckily, they didn't have the security in place that would prevent us from the web crawling. Then there are archives are there, Sami, Daedalus, and Agilas at the university library. So we collected the scientific article, legal documents, and educational materials. And after collecting, we have to process the data. And this data were available in multiple formats, like text file, HTML files, PDF file, the XML documents. And the challenges was there were many other challenges which we saw when we collected this data. Like when there were challenges of reading the PDF. Now, after collection, we collected this data set and we named this particular data set as SALT, like Sami LLM Token data set. Sami people are very nice people, very, I have talked to 2-3 Sami people who are not a researcher, and they are very good people, very open, can talk a lot. Now, in the pre-processing step, what we got that there are many non-Sami texts were there, and we needed to exclude those non-Sami texts. And there were multiple space, so we had to do the space normalization. And after doing this pre-processing, we wanted to make it a standard, better readable format. So we did the serialization and converted them into JSON format. And after that, we do have to create advanced cleaner because we needed to detect Sami text from, because many Arabic texts, many African texts, many European language texts were there. And those were ASCII code of different language. And we struggled actually for almost 1.5 months to find how to extract Sami text. So we did have to develop a classifier to detect the Sami language. And we used this fast text model. And this particular model has a confidence score of 85% to detect Sami text. And after that, we did a garbage collection and then deduplication. And that's how we created this Sami LLM token dataset. Now, in the tokenization process, also the challenges were there. Now, if we send this PDF or JSON file to OpenAI, the OpenAI will not be able to do a tokenization because Sami tokenizer is not available, and the Sami language structures is very different. So we had to develop our own tokenizer. And for doing that, we limited the vocabulary size into 25,000. Then the subword tokenization method like byte pair encoding we used. And by that, because Sami is a very complex language, Sami language is a very complex language, and we did it. And after that, we trained the tokenizer, and that's how we built the tokenizer for Sami language. So data collection, data filtering, then the tokenizer builder for detecting Sami text. And after doing all the thing, we finally have 22 million tokens in this SALT dataset, and which has around 2 million sentences. So considering that every sentence have 10 tokens, and these are the text from administrative document, religious document like Bible. So in the language dataset collection for low resource language, one of the go-to resource is Bible and Quran or religious books converted into those language. And Bible typically have 400,000 words. So that very good translated language we can get. Then the non-fiction books, fiction books, legal document, news. Like we collected data from Sami TV, which comes with a subtitle. And from that, we collected data, then science magazine and science books and the blogs and Reddit written in Sami, etc. We are not making the dataset open currently because we are still collecting the dataset. But we can talk with the collaborating on it with a larger dataset resource. If people are working towards, let's say, Oscar and Bloom, and they want to integrate this Sami dataset into that, then we can work with them. Now, when we go for language modeling, this normally what we do, auto-regressive token prediction we do, and then transfer learning, because we normally if we do the random weight initialization of the large language model, then the amount of data required is large. So, but pre-trained data and then doing the transfer learning works better. That is what we found also. And in order to improve our efficiency, we use the other similar language like Finnish, Hungarian. And we did include a Norwegian because we are working in Norway and we wanted to have this multilingual language where majority of Norwegian speaker also can use it. And after that, when we do go for the training, then the next token prediction is also a task, which is similar to any language training. Now, the transfer learning we found is very important, and the benefits of the transfer learning for this ultra low resource language is quite important. And using the cross-lingual trained learning helps, what we found. And using the similar language helps in performance or perplexity score of the language. So we use Finnish and Hungarian. We did try Sami only, Finnish only, Norwegian only, then Norwegian and Sami, then Finnish, Hungarian and Sami, then combining Finnish, Hungarian, Sami and Norwegian. So that is what we do. And since we work quite a bit on getting a very good quality data, even we are not a native speaker. If you are a native speaker, we can create other language translation tasks pretty well. But the data collection we have done is quite good. And so even with a less amount of data, to fine-tuning with a high quality data gives a better performance. So some observation we saw is the superior performance by doing cross-lingual training and using good quality data. And this also helps in efficient training. Like if we use a pre-trained model, the efficiency of inference is higher. And it also helps in resource optimization. Using the less amount of GPU resource, we can do this training. So the size of this well-manicured data is only 500 megabyte in the SOL data set. And but we added the other language like Finnish and Norwegian. And while doing that, we did took care of data balance. So we didn't, now this is a 500 MB data. So Finnish and Norwegian data, we use 1 gigabyte only. So that if we use more data from Finnish and Norwegian, there are more data available in that language. So it will bias the performance of Sami language. So Sami language performance will go bad. And in order to use a randomization, then we use the non-consecutive data feeding during the multilingual training. So observation, we found that there is a performance disparity if the data size is low. And the improvement in the Northern Sami is minimal if you only use the Northern Sami. So by using multiple language, we can increase. And what we found is the inference speed increased by twice if we use the pre-trained model versus a random initialization. And one thing we observed that domain-specific bias is there in our current foundational model on Sami, because the most of the data we use is from administrative data, administrative resources. So it is biased towards the administrative kind of language translation. Implementation-wise, we have done this kind of parameter configuration for doing this. And the vocabulary size was used 96,000. The model dimension is 1024. The layers used 2. The max position 512 embeddings we have used. And we actually tokenize, concatenated, and then split into the batches. Adam optimizer was being used for training it. If we go see the result, so if you see in this table, the S means sequence to sequence model. Pegasus model was being used, and cross entropy loss and perplexity loss calculated, self-belief score, and inference time. And D1 is where we use the random initialization for decoder only model. So we use Bloom and Bloom also lighter Bloom, not the full Bloom. And for D2, which is we have used pre-trained weight and Sami language only. And in the D3 model, we use the multiple language. And there we see the cross entropy loss becomes better. And though we do not get a higher perplexity, but overall performance quite reasonable when we do the multilingual training. So one of the example result for the multilingual trained model, so where the input was being given English and what we got is a Sami output. As you can see that it says that dog chasing the balls in the park team have also big part and sign. In team, Motor Fanet have many famous people. When she and he have a small skip last that he avoid himself long time being quested. Now, one thing we have observed that because of lack of amount of data, long context, these models are missing. So if we use it, stop losing the context if the amount of data entered is very long. So that is one challenge still there. Need to work further to improve this data set. One drawback of this particular model is that, means any foundational model which is trained, they are supposed to be guardrail. And guardrailing means a model should not be doing any kind of gender bias or any violating the fundamental rights, or especially the hate speech, which should not be giving out. So the presence of harmful, because the data set collection online, and this has a harmful, offensive Reddit data, and all those data are there. So lots of data in the training data has some harmful content. So as a result, the finally trained language is not guaranteed to give non-abusive language. And this type of data can lead to output which can have the hate speech and profanity and threat words. The reason that we are not able to make the guardrail because we were unable to find any classifier which can be able to do the guardrailing for Sami language. And the time we have put on this is 6 months, and we didn't found a time to develop a classifier ourselves, which can do the guardrail. And hoping going forward, there are a lot of development happening in Finnish and other language. We will be hoping that we can get a better guardrail. So once the guardrail we get, then we can release this data set. In summary, if we want to move for any low resource language or ultra low resource language, the challenges like data scarcity and cost of manual data collection and not knowing the language, the people who are working on this LLM research is there. Transfer learning helps. Joint multilingual training of similar language can improve the model performance. And utilizing better metric like cross entropy loss and perplexity can help in assessing and refining the ULN model, like what kind of parameter configuration need to be chosen, which can be better judged to check this model metrics so that we can fine tune the better configuration. So finally, I want to acknowledge the Prof. Laura Janda, who is a linguistic researcher at UIT, and resource we obtained from Vilentenko and Sami Ditlas. And many thanks to Dr. Santipriya Parida. So I met him last year when Finnish AI annual event. And I really liked him. The first instant I talked to him, I say, what a nice person he is. And then we collaborated further on this. This work is done primarily by Ronnie Paul and Himanshu. So they have worked quite closely and worked very hard for it. And me and Dr. Santipriya has been provide a supervisory and supportive role. So if any question you have, then now is a time of question. Thank you.
Thank you, sir, for this enlightening and engaging talk. So everybody, please, this is time. Like, if you have any question.
Yes,
Can I
James.
ask a question? Hello. Hi, sir.
Yes.
I had two questions. One is that in the data set that you have, the SAMI data set you have, what is the percentage of offline data you have? Means in the term of books and resources, offline resources. Do you have that kind of data set?
In our data set, there is no offline data is there. Means we didn't do any imaging of a book, and using OCR text extraction, we haven't done it.
Because I believe it will be more accurate version of the SAMI line. You know, if we can get the books and then all that.
True.
Right.
True.
And the second is regarding the guard railing issue that we faced, right? So is guard railing failure. So in this context also you don't have enough data, right?
We don't have the classifier. So you know the famous guardrail which is available by NVIDIA called Nemo, right? So if we put a Nemo, then any normal language guardrailing we can do. We just put an API of Nemo and this guardrailing automatically done.
Right.
But that guardrailing or other guardrails available doesn't work for Sami language. So Sami language, this trained model still can generate the hate speeches.
So
Like if you say that do you think this person is bad? And if he's bad, then no, you say that this person is bad. Give slang, 5 slang words for this particular person. It is going to generate the slang in Sami for that person because there is no guardrail there. So we will work further to find a guardrail or develop a classifier which can do the guardrailing.
Okay. So my suggestion would be that if you don't have enough data, maybe we can use the English version of the, you know, let's say if someone is typing how to make a bomb, right? It's you know something. It's kind of threat, right? So you can ask your professor to convert that into Sami language translation because they do helping in translation in Sami, right?
Yeah. So that is a very good input. Any other thing?
No, currently I have gone through that, but I'm more than happy to, you know, invest time in this aspect as well.
Yeah, that will be great, James. So, so if you think that what help we get from the Prof. Laura Janda is we only got where is the resource, online resource available.
Right.
We haven't got any further than means if we can get translation. So our foundational model cannot do the chat in Sami because there is no RLHF is done.
So even if we have the offline books, we can go to the OCR. I'm sure there is online resources to do the OCR.
Yes. You know, the Norway is a very expensive country.
But India is cheap, so I think it's manageable. If you...
I'm telling you what is the pricing is there.
Okay.
1 year of resource in Norway is going to cost me 1.5 crore rupees.
Okay, you can hire, I think,
so that is the pricing university is going to charge me. Okay. And now I do not have any project on it.
Okay.
So, but we are writing project like many project we are writing and grant we are writing, and Sami is becoming a part of it. So in future, but if you like to collaborate on it, then I will be very happy to collaborate to
yes,
make it.
I myself is also into generative AI field, and I'm also working. I have 10 years of experience in website application development. So I'm sure I can contribute in this aspect as
That
well.
will be great. I would like to connect it with you and work further on it.
Sure. Thank you so much, sir.
Any other question people have?
If not, then sir, I have a question. I might sound stupid, but I want to ask. Like when you mentioned, like you are able to translate from English to Sami, but you don't have resource from Sami to English. Like, is not is the same? Like, what is the challenge?
It's not the same. The language concept is very different.
So could you please elaborate a bit, if possible?
So from English to Sami, we can get translation. We can do it, but the resource which is available, which gives a good Sami translation of from English to Sami, we have to do it manually. Manually copy paste, and
Okay.
so we did not have enough manpower to do it manually. If you think that one person practically is working on it, and so would like to do that. So in fact, I actually suggested them. Then they say that let's first finish the task. That one we do next time.
Okay. Yeah, got it. So we don't have any online resource to do that. Yeah.
There is no automatic online conversion. Like there is a Galatenko. This particular they have you have to manually copy paste, and then that it does the translation. So some kind of copy pasting and translated data extraction, that automated testing tool need to be created where it will load the website and put and then extract, put and extract. So that need to be built up, and that way automatic translation can be done. So we can work on that further. So then this can become a quite interactive foundational model, and then lots of synthetic data we will have.
Yes. Yeah, got it. Thank you.
Just one question from my side, to Dilip. So we are telling that LLM, okay? I have not worked on LLM more. So, but if the data size is very low for the low resource languages, so how LLM is going to be fit there? Getting or not? And we are not doing also manual evaluation, anything, whatever output we are getting. So because GenAI is your GAN extended version, so we are going to generate either image or text like that only. So if we have a very small number of data for the low resource language, and we are applying their LLM, we are going to apply their LLM. So how? I'm not getting. Yeah.
So the thing is that first of all, this if you think that 22 million token is there, one easy way is we can use PLM, not LLM. We can go into BERT kind of model, which can be trained to do so now this prior to LLM model, they can do a very simple task. They are not, means if you are training it for translation task, it is only going to work for translation. If you are training it for summarization task, then they will only work for summarization. But what we see in LLM, that across 12 to 13 tasks, it is getting trained simultaneously. That ability LLM has. Now, since the amount of resource available is low, so we had to choose a small size LLM model. So like we use the Bloom, the lighter version, which has not a million parameter, which still have a billion parameter, but it is quite low compared to.
Not like Gemma, that all those models.
No, those are like, presently you have 456 billion parameter model and even 1 trillion. Like if you want to train with 6 trillion tokens, then they are going for a trillions size LLM model. So we are not using that size. We are still into sub-billion parameter mode. as
So
we
to
increase the
use this
resources,
blue model, Dr. Dilip, so whether we require the GPU again or always GPU
yes,
is
yes.
LLM?
No, so once you train it, then you can, if you want to use it on a CPU version, then the inference time, the amount of compute required is lesser than the training time. So how much time it is going to give you a response depend on how many floating point operation your model is going to take during the inference. So every model have dedicated flops. So if you want to use it for that, and after getting trained, using the model compression, this model can be compressed further. So which then can become a few million parameters, and then it can even go into your wearable watch, where you can talk with your hello kind of thing.
Okay, thank you.
Sir,
Any questions
as
from
you,
other? Yeah, yes, Joy.
sir, as you said that you have translations available for Sami to English, but not from English to Sami. So, for the guardrailing problem, is it not possible that internally the model translates the question to English and then apply guardrailing on the English text?
That is possible. That is one approach we can do in future.
And sir,
Many Indic language are also doing the same thing. Like I work in ASR, automatic speech recognition, where one approach is that any language convert into English and do whatever you want to do in English. So that is one of the way people are working on it.
Okay, so but as you said that the translation, uh, like if you apply the model, are the translations from English to Sami accurate?
From other language to Sami is accurate, because this Gilitenko online resource is good.
Okay, sir.
So they are working almost 20 to 23 years on digitizing Sami and developing this kind of Sami resources.
Okay, thanks.
Sir, one question from me.
Yes,
Sir, have you tried any prompt designing for this, sir?
what designing?
Prompt and response based, or have you tried any taking small data set and fine tuning the model, particularly for a specific downstream task?
We have tried for downstream tasks like plagiarism
Apart from the
detection.
machine translation.
No,
Yes.
plagiarism detection we have tried, and it works quite good with the plagiarism detection.
Any other downstream tasks like sentiment analysis or
We haven't done yet.
apart from this?
We haven't done yet.
And so you have not fine-tuned it for any particular task?
We have not fine-tuned it. So we have started working on it since December, and now it is May. So we will work further.
So because I'm asking this, so when I'm trying the same for Odia language, right now we are collecting, me and Joya, we are working together, and our most time went to the data collection and the data annotation part. After that also we are trying for data augmentation, but data augmentation actually is not working. It's not fitting to our context of Odia because of this grammatical structure construct. And existing model, when I tried for Odia, that too Odia is quite developed in the Sami language. Still, we are facing the exact aspects, exact tokens. It's not coming accurately. Whatever score you will take, perplexity or anyone, even we have tried for our kappa score and all for our inter-annotator agreement. Mathematically, it sounds well, but when we come internally structure, when I tried, still this Odia context is missing. So fine-tuning the existing English model and just translating back to low resource is, I don't think it's an accurate contribution to the Indic language work. What do you say, sir, in this way?
So what is your question, Lipika? I understand the challenges, but what is your question? I actually missed your question.
Yes, sir. Somehow I asked the questions and to some extent replied the answer as well.
Okay.
Thing is that how you progress towards the this for LLM are the two prevalent tasks, either go for prompt engineering or fine tuning. Am I right, sir?
After you get this foundational model, then you actually do RLHF for various kind of tasks like summarization, translation, then prompting, which is a chatting, basically chatbot you are creating, then finding the analysis, giving the hypothesis. So there are 13 to 14 NLP tasks are there. If you create a data set for those tasks, you can fine tune for the foundational model for those tasks, then it will work.
Correct, sir. Thank you.
Hello, sir. Good
Yeah.
morning, sir.
Yes.
Yeah, sir. Actually, just I have joined, and people are asking about that machine translation related questions, etc. So my maybe basic question, sir, like I have to collect the data set. I am also exploring my area in machine translation. So suppose I want to translate, suppose I want to collect the data set of Odia to Hindi, correct? So since parallel data is not available, I think so much. So I have only Odia data set. So how I can create the parallel data set, and what is the sample size should I take to start the machine translation? So these are some question I have.
So currently what I saw that this Indic LLM suite and Setu, this kind of work has came up in India. I guess translating from Odia to Hindi, those LLM suite, as per the score they are giving, they should be able to do it quite well. Because in this Sangraha, the amount of token they have is close to 500 billion. So 500 billion size token they have in Sangraha dataset, which is verified, unverified, and synthetic. So you can explore that, this Sangraha dataset, and see whether it helps you.
So is it too good to create the data set by using any means like you are telling that this website,
Yes,
whatever
you can.
LLM?
That is what currently people are doing, synthetically creating the dataset.
Okay.
The manually manicured data is not available. Means if a human is not doing the translation and correcting the translation,
Correct.
so that is another way people are augmenting the data.
Okay. So what minimum sample size should I take to start? Suppose like 50,000, 60,000 samples. What should I take? How much samples should I collect to start the work?
So sample size, it depends, So what we found that sequence to sequence model doesn't work pretty well. So decoder only model works well. And there, if you want to get a reasonable amount of, means if your pre-trained model is already similar to the the language you are trying, there the amount of token size, even 5-10 million should work. But if your means in a reasonable aspect, if you are looking for a very high perplexity score, you have to increase the data. So if you have a less amount of data, the size of the model you are going forward should be a smaller. Cannot start with 7 billion, 32 billion parameter.
Okay, so last question. Suppose, sir, whatever language I am taking, so to choose the model, is it necessary to support that language or not?
I am not able to understand your question.
Sir,
So
suppose I am taking any model and that language that is not supporting the Odia language. So is it can I choose that model?
you can choose that model if you know that in that model, similar language like Odia, for example, Bengali, Assamese are similar language like Odia. They have a
Okay.
similar language construct. If that kind of data is there in that model, means it has been pre-trained on that, then you using for Odia language, you are going to get a better performance.
Okay, thank you, sir.
Okay, I think we are a bit over time now. So, anybody is having any questions, or we can wrap up this session?
So there is a screen question is there. Yes, thank you. That approach automated, that API need to be created, which can do that. That is one moving forward and steps we need to do.
Okay, I think that's all. So, sir, thanks a lot for this such an enlightening talk. Thank you for joining us today. And Professor Dilip will be providing summer course. If anybody is interested, please connect with him and submit your application.
So let me make an announcement. So I am conducting this generative AI course, which is offering now in a hybrid mode. Physically, there are some Norwegian students are attending, and which is also now opening it to online mode. So all the assignment and project work, it will have around 50, 60 hours of project work in generative AI, and that will be the learning part. So, and if you are attending the lectures, which is 15, 16 hours of lectures, and an assignment and hands-on lab, then you can get the participation certificate signed by us. So this particular course has been organized by me, Dr. Santi Priya, Dr. Himanshu, and others. So if you are interested, drop an email to me, like Dilip Prasad, dilip.prasad@uit.no. So, or Dr. Santi Priya can send email, like, or KIIT faculties can send an email to students if you want to attend. So the course will be conducted last week. Some online will be there. Last week of June, some online lectures will be there. But then finally on 5th, 6th, and 7th August, lectures will be there. And other time it will be digital consultation, one-to-one consultation related to project. It's very much like working on a project. And based on 7-8 page project report, you will be evaluated, and if you turn out to be a good work, then you can publish that work also. Any question? Thank you, Smriti and OdiaGenAI and Dr. Santipriya for inviting me. I'm really glad so much interest is there. And I hope more students join in the course. So that will be fun.
Thank you. Thank you,
Yeah,
Dr.
thank you,
Dilip.
sir.